You hear it all the time, right? AI that thinks. But what's really going on under the hood? How in the world can a bunch of code and circuits actually reason like a person? Well, it's not magic. It's actually a pretty elegant logic engine, and today we're going to pop the hood and see exactly how it works.
It really all boils down to this one question. You give an AI a bunch of facts, how does it connect the dots to figure out something new? The process is surprisingly simple, and it all kicks off with one core idea.
All right, so the entire process really hinges on one single powerful concept. And no, it's not magic. It's the bedrock of how these machines actually think.
And that concept is called inference. You can think of it as the AI's ability to read between the lines. It's the engine that helps it figure out what's implied by the data, even if it's not spelled out. This is absolutely fundamental for everything from understanding language to solving really complex problems.
So how does an AI actually do inference? Well, there are a couple of ways. Let's start with the most basic approach, logic that uses fixed, totally unchangeable pieces.
This is something called propositional logic. Basically, it works with concrete facts about the world. Any given statement is either true or it's false. There's no gray area, and the statements themselves don't really have any moving parts.
Take this classic sentence, for example. In propositional logic, this entire statement is treated as one single, indivisible chunk of information. The AI has no idea what a cat is or a mat. It just knows that the statement, "the cat is on the mat," is either a true thing or a false thing. Period.
So, you see the problem here, right? The system is just incredibly rigid. Each fact is like a unique puzzle piece that only fits in one single spot. It's simple, sure, but it's not flexible at all. It just can't handle general rules or big abstract ideas. For that, we're going to need a major upgrade.
So let's talk about that upgrade. We need a much more powerful system, one that uses variables. And this, right here, is where AI reasoning starts to get really flexible. And the difference between these two is just massive. Propositional logic is stuck dealing with specific, one-off facts, like the cat is on the mat. But first-order logic, it can handle abstract general rules by using variables and symbols. This is the kind of knowledge you can apply to almost any situation.
You see, this new system gives us an amazing toolkit. We get variables like x that can stand in for pretty much anything. We get things called quantifiers to make big, sweeping statements like for all things or there exists at least one. And we get predicates, statements whose truth actually depends on what those variables are. This is the language of general rules.
But this powerful new system, well, it creates a really interesting new challenge. How does the AI connect its big general rules to the specific concrete facts it knows about the world? This is the central puzzle we have to solve. Let's use probably the most famous example in all of logic. Okay, so the AI knows two things. One, a general rule. For anything x, if x is a human, then x is mortal. And two, a specific fact. Socrates is a human. Now the conclusion seems totally obvious to us, right? But how does a machine make that leap?
And that is the heart of the puzzle. The AI's rule uses this abstract variable, x, but its fact uses a concrete name, Socrates. How on earth does it figure out that human x and human Socrates are even talking about the same concept?
Well, the solution is this beautiful two-step process. It's an algorithm that lets the AI perfectly matches general rules to specific examples. This is the real aha moment. Okay, so this is how the AI connects the dots. First, it looks for a match. It compares the human x part of its rule with the facts it knows, and bam, it finds human Socrates. So the next step is to unify them. The AI figures out, hey, if I just swap out the variable x for the name Socrates, these two things become identical. This substitution, where x becomes Socrates, is the key. And now for the really cool part, lifting. It takes that key and doesn't just apply it to that one little part, it lifts it and applies it to the entire general rule. So the abstract rule, human x implies mortal x, instantly transforms into a specific one, human Socrates implies mortal Socrates. And since the AI already knows Socrates is human, the conclusion is unavoidable. Socrates must be mortal. That's the whole process. That is the engine.
So, let's just put a name on that first part, unification. That's the detective work. It's the algorithm that systematically hunts for a way to make two different expressions match up perfectly just by substituting variables. It's what finds that crucial link between the abstract x and the concrete Socrates.
And lifting, well, that's the masterstroke. It takes the specific key that unification found and uses it to unlock the full power of the general rule. It applies that substitution to the whole shebang, lifting it up to make the general rule useful in a specific case.
Okay, so that's a pretty clever logical trick. But why is this two-part engine so incredibly important for the entire field of artificial intelligence? What's the big deal?
Because this is what makes true machine reasoning possible. It allows an AI to go way beyond just literal text, to make logical deductions, to update its own knowledge base with new information, and even to start making predictions by applying its general rules to new data. And really, this is the main takeaway. This elegant little dance between finding a match and then applying it everywhere, it isn't some minor detail. It is the fundamental engine that drives logical thinking in countless AI systems out there today.
So, we've built a machine that can actually prove things are true, based on the information it's been given. And that leaves us with a much bigger, much more profound question. As we move forward, what rules, what facts, and what truths are we going to choose to put inside that engine?